welcome to part 2 of the Tearing Vellum setup. And in this section, I'm going to show you how you can set up a custom Vellum constraint to create your own glue constraint. It's optional, you don't need this, and that's why I'm doing this as a separate video. So if you want to ignore this and go straight to meshing, you can skip this section. But in this section, I'm going to use a bit of X to make my own glue constraint, and I'll give you some other extra tips about the setup. I'm leaving where we left off with as a starting point, and I've just got a sphere and I removed the noise from it. And if we go back to Vellum setup, you'll see I removed the collision for now, and I've kept the backbone of everything else, just so we have something to test with. And this was our setup that we had. Let me just show you what I don't like about this glue constraint, and maybe it's just me using it wrong, but I always get frustrated about how it leaves points unattached. So this is the same settings we were using for our previous simulation. And we can see there's a couple of points that don't have neighbors, or they definitely should have connections because we've said it should have 6 connections, and we're searching for a couple of points. So maybe I should search for more points. So if I bump this up to 10, it's slightly better. But everything's still not connected. I can change this radius. Now it looks like, in this case, we might have everything connected. So let's change this amount. Let's say 8 connections per point. And we see if there's 8 connections per point, it's all getting a whole bunch of connections now, which is good. Now if I go down to say like 3 connections per point, all of a sudden, like, we've got points not connected to each other again, which, to me, it makes no sense. I don't know why it behaves like that. We've got minimum radius, which makes sense, and we got maximum radius, which makes sense. You can bump that up, so it should be finding enough points now. And this changed a bit. We still have a stray point over there. So I'm just going to show you an alternative setup that I used to get around these values that are mainly just confusing me. Okay, so I'm going to get rid of this glue constraint and give myself a little bit more space. And I'll keep our break threshold. So to start off with, I'm going to create a wrangle, because this is going to be a little bit of X, and I want to find all my neighbors. And to do that, I'm going to create a point array, and I'm going to use a PC find function. And I want to search the 0th input because I want to look at the points that I already have. And I want to search the position based on my point position. And then we can give it a maximum radius and a maximum amount of points to search. And these might be good to turn into controls. So let's say, let's a variable called rad for radius, and PTS, or I've already used PTS. Let's call that, let's call it max for max points. And I'm going to create 2 channels for that. So one's going to be a float, and it's going to be rad, and I'll call that channel F, and it's going to be search radius. And the integer is going to be max, and I'll call that channel I. And that's going to be my connection. So I'm going to call it max connections, like that. And if I create those 2, that should work. And for now, I'll set the radius really high, like 100. And let's give, we were using 6 connections before, so let me see that to 6. If we're looking for 6 points, the first point that it's going to find in the function is going to be ourselves, because it's looking at that point cloud, and we want to remove ourselves from that search. So what I'm going to do is get a remove value. So what I'm going to do is get a remove value, and I'm going to use that to, from that array called PTS, remove the value that's equal to the point number of the current point. So that'll give us an array that doesn't have the point finding itself in there. And this I'm just going to write to a new array. So this is going to be I, open and close block brackets, and then I'll call this array PTS. It's going to be equal to PTS. And now we should get that value. If I go over to points, you'll see I've got an array and it's finding 5 points for each, which makes sense because we're removing the first one. So if you want this number to make more sense, probably a good idea to +1. Now we're getting 6 points and we're looking for 6 neighbors. Set that down to 2 points. Each point is getting 2 neighbors. Visualize point numbers. Let's find there's point 1. That was lucky. And if we look at point 1, it's getting point number 23, point number 3. That's its neighbors. And we can see there's number 23 and there's number 3. We can set this back to 6. Okay, so we know this part is working. And what I'm doing is building a function similar to the connect adjacent pieces. I'm going to create this array first, so I know what connections I have. And then in a second wrangle, I am going to make these connections and set up the rules slightly differently. So to do that, I'm going to create another wrangle. And it's probably good to name these, so I'll call this find connections or potential connections. And in this one, we're going to make the actual primitives. So for this one, we can call it make connections. And the first thing I want to do is I want to turn that array back into a variable. So I'll get that array attribute that I created called TS, and then we're gonna want to loop over that array. So I'll create a for each loop. For each int I, and I'm just gonna loop over that whole array called PTS. Close that. Okay, inside the for each loop, what I'm going to do is I'm going to compare my point array to the point array of the neighbors that it's found in this previous point search. That way I'm going to compare if the connection is happening between both points. So I'm going to try and make any connection possible. So it's going to have 2 conditions instead of just the one condition that the connect adjacent pieces has, and this gives us an extra chance to make connection between points. It's a little bit vague right now, but let me write the code and hopefully it makes a little bit more sense then. Okay, so first I want to find the array that our opposite point that we're looking at in the loop has. So creating an attribute called OPTS, and I'm going to look at that point attribute, which is going to be its array attribute. And I'll use the point function to do that. Then I need to find a value in that array. Let's say int found equals, and then I want to find if the current ptnum is in that array. So I'll use a find again, and I'll say OPTS, and I'll say add ptnum. Now I know a little bit more about the values in that array. And I'm getting an error because I didn't set that to be an array. I just set a regular integer. It should fix that. So if it doesn't find the current ptnum in that opposite array, we know we can create a connection between those 2 points. And I just want to create a integer attribute, which is going to be for our new primitive. And I'm going to do that outside of the loop, so we don't have to call it multiple times. So I'll call that new prim. If that find didn't find anything, it's going to return a negative value. So I can say if found is less than 0, curly brackets, close that, and then I can add a new prim. So that new prim is called new prim. It's a variable we just created. And then I can add a primitive with the add prim function. And it's going to be in object 0, and I want to create a polyline. And that polyline is going to be between current point and I in the array. If we click away, we can see we get a few connections, so that's a good start, but it's definitely not anywhere in the range of 6. So now we're going to use an else, use a different rule if it has found a neighbor. So let's say else, and add another if in there, and then I'll use if ptnum is greater than I, close that bracket. Again, it's going to be new prim. And if that's true, I'm going to add a prim with the add prim function. And actually, let's just copy from our previous one. Now we should get a lot of connections. So everything's connected, and also there's still not going to be any overlapping connections. Now we can probably work this out. If I set this to 2 connections, if you middle click on this, getting 500 points, I'm getting about 700 connections. We can see everything is connected. Even if we go to these low values, even if we do 1 connection, you can see getting almost the same amount of primitives as points. Some of the primitives are connecting, some of the points are, because we get points connecting different primitives, but getting all those attached points, and as we bump this up, like just getting very predictable results. Our connections are working now, but we still need to create some attributes on these primitives so Vellum knows what to do with it. And we can set it up directly when we make the points. That's why I created that new prim integer. Otherwise, you can always change these on the primitives afterwards as well. So I'll create new primitive attributes. And the first one I want to make is the constraint type. So I'll just call it type. And I'll use that new prim as the prim to create that type on, and it's going to be a string called stitch. That's the first attribute we need. And then the next one I'm going to create is a constraint tag. And it's also going to be on the new prim like all the other ones. And this one is one we can give a name. So that's how we can name our constraint. So I'm going to create a channel for that so we can control that. And I'll call that constraint tag. like that. And we're just going to keep going, creating another few. We'll just copy this so it's a little bit quicker. We need to set up our stiffness. So to do that, we need a value called stiffness. And this is going to be a channel F. And we can call it stiffness. We also need some damping. So we need to set damping ratio. Call this one damping. And if we want to be able to break it, we're going to have to set up a break threshold and the type of break as well. So the break threshold will be break threshold. And we can copy that for the name as well. It's also going to be a float. And the type is going to be a string. And we'll call that break type. And again, I'll probably just copy that across. And I'll create all of these. So the tag, I'll call it my glue. Give it a stiffness of 10,000 and a damping ratio of 0.01. Break threshold of 0.2. And then the break type, and just see what the correct naming is. I'll get a Vellum constraint. I should have kept the glue constraint, so we can reference that. I'll just quickly set this up. Points and points, and make some connections. And if we want to continue on using stretch distance, then I need to call that constraint stretch distance. Like that, and that should almost be enough for us to test this, but we do need a rest length as well. For that, we can just get a measure sop, and we can measure the perimeter, call this rest length. And I think we want to duplicate that attribute. Yes, we do, to get this rest length orig for original rest length. So for that, I'll just use an attribute swap. And it's going to be a primitive attribute, and I want to copy it, and the source is going to be rest length, and I want to do the rest length orig. And obviously this is a lot of work just to get a constraint working, but I definitely would wrap this up into an OTL when I'm done with it. I might just do that for you and share this one. Okay, now you can see if we switch between this glue constraint and the arc constraint, it looks like all attributes are accounted for. We're not nearly as stiff as that one by default. Maybe give it a little bit more stiffness. Delete that glue again, and let's see if this actually works. We don't have any variable breakage in this at the moment. But this should still work. And I'm gonna need a new collision for this because I removed the other one. So I'll create a new geo. And this time, let's make a new box. Let's rotate this one sideways. See if we can get a different look on this. Maybe something like that. And call this collision. I'll change that name. This one should pick it up now, I think. Oh, I didn't create the out node. It's better. Now it should work. Let's see if our sum actually works. I didn't check my p scale. Go back to points. P scale is 0.048. 0.05. Let's hit play on that finally. Okay, we got some stuff stuck in the viewport, but that does look like it's working. I guess it's just my display. Let's jump up. Back in. There we go. Okay, but we can see that's working. It's sticking and our constraints are holding together and we don't have any random points popping off, which is nice. Now let's mess with these values a bit. I'll set my damping a lot higher, 0.2, reduce the stiffness to 1000. And maybe let's reduce this stiffness as well. Make it like 100 or make this like 1000 as well. Give this a little bit more damping. I'll hit play on that and let's see what happens. It's still not very exciting. They're holding together so well. Let's give them less connections. Get 100. This one 100. Just want to get it to stretch out a bit more. It just doesn't want to. Okay. Guess we're probably way overdoing it with substeps and stuff on this one now because it's still the old settings. It's going to drop all of this stuff back a bit. And it's not, let's see. Let's say stiffness of 10. And I think I might have them actually, they're probably still wet as well, so they're trying to hold together. So I'm going to turn that off. Make this a stiffness of 10. Trying to get it to stretch out a bit. It's holding together better than I thought it would, without like putting any other forces in there. Now we're getting a bit of stretching. It's making almost like a teardrop shape as it's hanging there. Still not kind of breaking apart or anything. Because we do still need to check that the braking is working. So what I'll do is I'm just going to introduce another collision object like we did before. Let's add a sphere to this time. And this was falling up to about there. So move the sphere into initial position, something like that. Oops, don't want to scale it, just want to move it. And then I'll get a transform to animated. I like to have my animation separate. So I'll give about 16 frames there. And animate it that way. Set another key, merge it in. It's a little bit easier when you're collision to one object. Set a trail, you can see the sun is freaking out a bit. And I'll dive inside, see what our simulation is doing now. And I'll turn on show thickness. I wanted to hide gray spheres, but it looks like it's a bit offset, so I'm going to turn that off. Now we're getting it stuck on both ends, it's pulling, and it's tearing some bits off. So you can see this is working just like the out-of-the-box stuff. That's really what we wanted to check. So that's working really nicely. And I'm pretty happy with that. So that's how we can make a custom setup. And before we wrap up, let me just show you how you can get this break threshold scale to multiply in the same way we've got it set up in the regular Vellum constraint. So we can use an attribute copy. And with the attribute copy, we want to get our points. And the safest is probably to do it while it's all still points. Actually, the point shouldn't change, so we can do it after the connections. And I'm going to get this break threshold scale, and I'm just going to copy it over to our constraint geometry, because by default, it doesn't get the attributes that are coming in from the points. So now we've got that point attribute on there, but we need to promote it to primitive. So we'll get an attribute promote. And I'll paste break threshold scale in there, and I'm just going to promote it to primitive. And it's set to average by default, and I'll leave it at average. So it just kind of averages out that noise between the 2 points of the primitive. But you can pick different types if you want to go for min or max or any other value. Should be able to display it as well, so we can see that it is there. Might want to change some of the settings on that now. But it's not doing anything yet. Get another wrangle and just multiply our break threshold by the break threshold scale, and then that should be set up. So we'll paste that name just for speed, and I'll say add break threshold scale. Paste it again, say times equals, and just remove scale from there. So we've got our break threshold. It should be attribute. And now it's break threshold times equals break threshold scale. I'm gonna remove that, maybe make the noise a bit smaller. Maybe that's too small. Maybe that was bad, yeah. Okay, let's do that. Set that a bit higher. Okay, now we should see a lot of it breaking a bit more easily. Let's see what happens when we play that. It's still sticking. That one's looking pretty similar, but I think it's different. Let's double check that's working. Still have the point attributes on there, which is bad. We probably need to clean that up a bit. Yeah, so I've got break threshold scale and break threshold on there, and I still have this array. That's always good to do a bit of cleanup work. So I'm going to delete all of that. We don't want that. I don't really want any of this stuff. It's just going to make our cache heavier. So now that's all gone. Let's See what our primitive constraints are doing. Okay, so our break threshold is being multiplied. That's our break threshold scale between. And that's not being multiplied because I forgot to set this to primitive. No wonder it was all looking the same. Now we should see a different result. Sorry about that. Okay, there we go. You can see this thing got a lot longer. It's just tearing in more places now. That's looking pretty cool. Turn that on if we want to see our stitch constraints. And we can see how that's working now. Cool, that's everything for this tutorial. Next up is going to be the meshing. Thanks for watching. Bye. If you want to see more videos like this, or if you just want to support me, go check out my Patreon page or follow me on Vimeo or YouTube. And if you like this video, give it a like. And as always, to all my patrons, thank you very much for your continued support. I can't do this without you guys.